Hello students, welcome back. Previously we studied histograms, including some advanced histograms, which is an optional topic. Now let's go to the next topic, which is OGIF. Here's a reminder, same data set and the same class interval. Again, we are coming back to standard case. The width is 10 all the time. Make it less. And then frequency, just count, or cumulative, this is a little bit different, excuse me. Frequency, just count and we get that. And then if you draw a histogram, you're going to get these boxes here. These boxes. For the time being, forget about this line graph and look at these boxes only. And this is the same histogram you did before, except that it is scaled a little bit because otherwise this would be too tall. So a little bit flattened, but it's the same histogram anyway. Now, I'm going to couple cumulative frequency associated with this in a line graph, and that's called the OGIF. What do you mean by cumulative frequency? You have to keep adding up. So first we have 1, and then nothing was added, so stay at 1. And then in the next class interval we have one more student, so cumulative, you have to add them up. So far we have 2 students. So 2 students below 60. And then we have 4 students in the next class interval, add them up. 2 plus 4, we get 6. Total 6 students, less than 70. Now we have 10 students in the next frequency, 10 students in the next class interval. Add them up, we have 16. Total 16 students, less than 80. Another cumulative frequency, keep adding up, and keep adding up. In the end, I have to have the total of 23. And these are the y coordinates, starting from 1 and then the center, and then 2, all these, all the way up to 23, add them up so that I get all those cumulative frequencies, and then join them, and that's the OGIF. And please notice, OGIF, this line graph part of the OGIF, always increase. It's cumulative frequency. You're keeping adding up. So always they have to increase, and increase all the way up to the total. Always the total. And some people start from 0, as a matter of fact. Instead of starting from here, starting from a little bit to the left and start from 0 and then all the way up to 1. But most people start from the top of the first box. In a sense, this is similar to Pareto diagram, but Pareto diagram actually changes the order. So it doesn't really work well with ordinal variable, but OGIF works for histogram. It's coupled with histogram. No change of the order, but as far as the cumulative frequency is concerned, it is related to Pareto diagram. You can, of course, change the class intervals. In the second picture here, I'm using a different class interval. As a matter of fact, I'm coupling it with advanced histogram, by the way, excuse me. Yeah, we have uneven interval width. So this time, area corresponds to the area corresponds to this relative frequency, excuse me. And then same shape of the box forms. But this one is a little bit advanced, so don't try to do this unless you know what you're doing. So average students, or if you're just above average students, just stick to standard histogram where interval widths are all the same all the time. It's much easier that way. Now, if you're designing your own statistical model, maybe for your own major, maybe for a senior project or something, unless you have to, try to use the same interval width. It'll make your math part a lot simpler. Now, if you have to, absolutely have to use different interval widths, then you cannot come back to typical 1680 mathematics. You have to use higher mathematics. And I give you a glimpse of it. You have to use those advanced histograms, and then frequencies or relative frequencies correspond to the area of the rectangle, not the height. Anyway, that's the algebra. Now, shall we go ahead with some example problems? Okay, here we go. The following table shows the monthly electricity usage of a certain household from June 2013 to June 2014. Produce a histogram and an algebra. And here it is. And as a matter of fact, it came with this kind of picture. I've actually used it in summer of 2014 as an exam problem. And it turned out, let's see, it was a summer course, so it is a little bit different from regular course, but still, even considering that, the performance was terrible as a matter of fact. Not a single student got it right. Everybody did it this way. This is a bar graph, it's not a histogram. Wait a minute, rectangles are touching each other, is it not? Well, yes, but that is not really the key of histogram. The key of histogram is horizontally class interval, that's the biggest, vertically frequency or relative frequency. Now, do we have class interval here? No, really, we have months. And then vertically, what do we have? Is that a frequency? Did you actually count and put integers there? No, those are just electricity usage. So this is a bar graph. It's not a histogram. And in that particular term, a summer term, no students got this problem right. And I was a little bit frustrated. So ever since then, so I'm keeping it as a regular problem. And I'm covering it every semester since then. So let's produce a correct histogram out of it. You see, this will be automatic 0. Let's produce a correct histogram. So what do you think is the best selection of the class intervals? Well, I decided to go with class interval size of 250. That's just my preference. 500 to 755, 755 to 1000, 1000 to 1250, and so on. And then just count how many months. And those are going to be the frequencies. Divide by total 13, and I'm going to get relative frequencies. Now, if you don't like 250, if you want to go with, say, 200, that's fine. But make sure you get sufficient number of boxes. As a matter of fact, how many class intervals are there? 1, 2, 3, 4, 5. 5 is actually a bare bone minimum. If you have less than 5 rectangles, the chances is not going to be good. If you have just 2 or 3, then of course that doesn't do any kind of justice to your data set. The reason 5 is really bare bone minimum is because, that reason will be answered in the next session. Not next session, next week, excuse me. Anyway, I got that. And then based upon these frequencies, I get this kind of picture. So from 500 to 750, 4 such months. Between 750 to 1000, 1. And then next 2 class intervals, 3 and 3 respectively, and then 2. So here is a histogram. Do you see any pattern? No, not really. Okay, now that we have histogram, let's produce an OGIF. OGIF comes with a histogram, but I have to get cumulative frequency as well, which will be the line graph. And pretend you don't see it yet. And let's find those out. Same class interval, same frequency, just count those months. And this time, let's find cumulative frequencies. Start with 4, and then 1 more, so add up. 3 more, so add up. Another 3 more, so add up. Finally, 2 more and add up. And did I get a total of 13? Yes, I did. So those are going to be the y coordinates. 4, 5, 8, 11, 13. And those are 4, 5, 8, 11, 13. This is 4, 5, 8, 11, 13, and all those points. And then join them with your ruler, and that's the OGIF. Now here I decided to start from 0, and then 0 to 4 we got that. But this part here, it's not really necessary. It's okay to start from the top of the first box. It's okay. But some people start from 0. Most people start from the top of the first box. Where do they end? Top of the last box. And the y coordinate has to be always a total. If you use relative frequency, then the total is always 1 or 100%. So that's the OGIF. Okay, pretty much done. And let's talk about one final topic on histograms. Types of histograms. Depending upon the outlines of histograms, we use these kind of terms. This kind of thing is called symmetric for obvious reasons. Left-hand side and right-hand side, pretty much okay. And normal or triangular, I'll try not to use these kind of terms. This one is uniform, and the height is about the same. Even if you have a little wriggling, and if it's roughly the same, we call it roughly uniform. And symmetric too, left-hand side, right-hand side, matches. Rectangular, again, I'll try not to use this kind of term. This is important, skewed to the right. Stretched to the right, start from something like this, symmetric, and stretch to the right, and we call it skewed to the right. Here, start from the symmetric and then stretch it to your left, call it skewed to the left. And this too is skewed to the right, but why is it called J-shaped? I don't know. And this thing is called bimodal, and there are 2 humps, 1 and 2. 1 peak, 2nd peak, there are 2 peaks, so bimodal. This one over here, this one, those are all unimodal, 1 hump. And this one is bimodal. And if you have 3 or more, then multimodal, but those examples are rare. Most of the time, you're going to consider either unimodal or bimodal, and those are classifications based upon the shapes of histograms. I guess I covered everything that is necessary here.